Chairman, gentlemen, thank you very much for giving me the opportunity here to share with you one of the recent technology breakthroughs which have been achieved, which are part of the story of the global interconnection, which is the 1100 kV converter transformer, which is the most powerful converter transformer in the world. But before I go a bit more detailed into that one, let me start from a historical picture. More than 60 years ago, the HVDC story started with a small installation from today's perspective in the island of Gotland, where we installed a 20 megawatt 100 kV DC. Now, today we are talking 600 times the power of that where we started from. And you can see on the graph, on the diagram, how the development took place over the years, over the decades, which is really impressive. And you will see in the following slides some very impressive further parameters. Now, as any good product development really addressing a breakthrough, it starts with a good technology development. And in February 2011, State Grid and ABB met in order to define first technology development parameters. We started from a target of 10.5 gigawatts, so 4,500 amps, and we started then by developing a prototype and manufacturing and testing it from the most critical components, which are the DC turret, the valve winding, and the cleats and leads. There was a significant need for power rating increase because at that time the technology was on a level of 800 kV and 8 gigawatt. And as there is no linear scaling of the components, we had to basically rethink the concepts and started the development from scratch. Only 16 months later, we were able, together with our customers and colleagues from State Grid, to test a successful prototype of the transformer and the bushings. Now, when we are talking bushings, the bushings are a substantial and also challenging part of the transformer. We are talking wall bushings as well as the transformer bushings. And the biggest challenge here was to transfer 50% more energy at even increased voltage level. So new concepts were of insulation in terms of thermal management as well as mechanical design. Now, when you compare the 1100 kV wall bushing, for example, to the 800 kV wall bushing, it was a 40% increase in length, a 30% increase in diameter, and really the production and testing environment was pushed to its limits. After the technology development, which was passed successfully, the productification started. And in the meantime, also our colleagues from State Grid got more and more clear specifications on the overall layout of the systems. And in frequent and regular interactions here, we developed then the final parameters. There was a further system power increase from 10.5 to 12 gigawatt level. So also all the test levels had to be increased. The transformer design was adjusted, for example, the dimensions, and then it came also for sure to the production and testing equipment. So in our lead factory, as an example, we had more than 50 investments specifically developed, which had to be done for the production itself. And you can see on the pictures 2 examples where really new limits have been achieved. Now, this slide is really to acknowledge this huge project with its dimensions. So 1100 kV, 12 gigawatt over a length of significantly more than 3,000 kilometers. And we have seen in many of the presentations today and just also in the last one that this is one of a number of very powerful systems and lines in China. But when, for example, I go to Europe and explain what we are doing there, this is, to put this into the ratio, this is twice the power of a country like Switzerland transferred all across Europe. Now, 5 months ago in November 2017, then we had together again with our colleagues and partners from State Grid the successful type testing in Ludwika. The final transformer now has a weight of 100 tons, a length of more than 30 meters, a power rating of more than 600 MVA connected to the 750 kV AC on the line side. This is really a historical breakthrough within the HVDC high power long distance transmission lines, and due to the excellent collaborations with our partners from State Grid, we could achieve all timelines. And this is not only valid for the transformer, this is also valid for the further delivery scope of ABB, which is the HVDC converters for the receiving stations, the wall bushings, and the neutral DC breakers. Now, why is this such a breakthrough for the initiative? First of all, it is an enabler for really the powerful long-distance transmission, what we have seen in the previous presentations, how important that is to build the backbone grid. But the development also continues in a way that we are going to DC grids, including DC breakers and the required system layout protection and control. We have heard already some content about that one. But what I want to specifically highlight here is future mixed systems of LCC and VSC. VSC, and we have heard it also, and I fully agree with that one, is getting more and more important and relevant. We are pushing voltage and power ratings in a significant way these days on the VSC technology. We are decreasing the losses. We can be more and more compact. We are improving the availability, and we are really adding new functionalities or full functionalities for grid support and, for example, black start capabilities. Now, in a combination of VSC, we can really realize the dream starting from today's installations, the dream which we have here shared today and which we all need so much in order to introduce a massive amount of renewables into the grid. So it will be a lot about system upgrades, mixed systems, and then really connecting the technologies. And here we are really talking concrete and tangible projects and ideas. One example here, the connection from Outer Mongolia via China to Korea and Japan, where the multi-terminal DC in a mixed way of LCC and VSC technology will become real. So let me share a little bit more on the outlook side. In line really with the idea of the interconnection, making the renewables really usable in a full-scale deployment, we need the global interconnection. We need also the mix of the AC and the DC. We need the backbone grids. Only with this development, and that is also in ABB really our we are fully convinced about that one, is that only in this way we will be able to achieve what we need to do. There will be also further an increased share of energy by wire, and we saw also in some of the morning presentations more on that one. And finally, as a next step, the massive introduction of grid-connected electrical vehicles will come and will add into this development. And again, China is a front-running country, and we see also in other regions of the world that this direction is important. Now, it's not just about the energy transfer, and we also heard about that one. We from ABB also believe that this connection of the energy transfer to a flexible data transfer will enable new business models, new way of exchanging the energy. And we have heard also today already about the need that these business models and the business cases have to be further developed. We need to get more push definitely from governmental side, but also from a business model side, and really connecting the grids also from an economic perspective in a good way together. Now, finally, last but not least, also in line with one of the speakers mentioned this morning already, artificial intelligence is a trend which is also coming, and it is helping us. It is helping us to manage the higher level of complexity in the grids, and it will enable more complex autonomous processes and sub-processes. So that is the vision for the future, which is becoming more and more real and which is also really a need. And the breakthrough of the 1100 kV converter transformer, which is really a tangible achievement from the last months, is one of the many important steps in that direction. Thank you very much for your attention.